Hi everyone, welcome back. Today we're doing shuffle strings in C++. We're given a string s and an integer array indices of the same length. The string s will be shuffled such that the character at a certain position move to indices in I, in this case, in the shuffled string. It's pretty cryptic, but what this means is we are given a string s and an array of indices, and each of these indices corresponds to each character's position's index, where it should be at after we move these characters to these indexes. So in this case, if C is given 4, then C should be at index 4 in the final shuffled string. If O is given 5, then O should be given and moved to index 5 in the new string. So in this case, if we move every single character to their corresponding index, we will get back Leetcode like this. So the length of S given to us in this case is equals to the length of indices. Makes sense because the indices represents each character's index, and this will be given an alias of n. And n in this case ranges from 1 to 100. S will consist of only lowercase English letters, and every single index is from 0 to less than n, which makes sense because they're indexes. And finally, all values of indices are unique, understandably also because they are indexes. So to do it, it's a little tricky in a sense such that if we're given a character at index 4, we have to move C to index 4 in a given final string. So the final string that we have needs to be of the same length as S in this case. So we will need something like a shell such that when we iterate the first character, even if the first character is given an index at the final position of the string, it must be able to move to that position, aka we need to assign a memory first. So to do that, we'll be assigning a shell string. This shell string will contain the same length as S, and once done, we will start iterating through S and indices from left to right. We will initialize an index equals to 0, and we will iterate this to S minus 1 index. For each of these indexes, we will get the corresponding character as well as the index for this character, and move this character to its corresponding current index. After iterating through every single character in S and indices, we should end up with a final restored string that is in order like this. So with that, let's get started. Let's define shuffled strings, a string shuffled string, and we will initialize this to have the size of s.length and give it an empty character like this. So a little background for our viewers who come from Java or Python background. In Java and Python, the string is immutable, so this doesn't work. Whenever you try to change something, it's going to take O(n) time to make a copy of that previous string because the previous string is immutable. But in this case, in C++, strings are mutable, so we can just use a string like this. In Python and in Java, we will use an iterable collection of characters instead. Because arrays are mutable, strings are not. So why not make a list that is mutable and use that instead? Afterwards, we will just join it back, but in C++, that's not necessary. So now that we have this string, we would start iterating through every single index. So in index equals to 0, index less than s.length, index plus plus. So using this index, we will get the current character. So let's do char, current char equals to s at index, and we will also get the corresponding char index, and this will be equals to indices at this given index. Once done, we would set this shuffled string to have this character at its corresponding character index and return shuffled string. And that's pretty much it. So to convince you that this works, let's copy this test case and trace this out so that we can see how this evolves. So right now we would have shuffled strings, and in this case, because our S over here has 8 characters, so shuffled strings will be 1, 2, 3, 4, 5, 6, 7, 8, length 8, consisting of multiple spaces. Actually, let's use a dummy character A, 1, 2, 3, 4, 5, 6, 7, 8 to make it clearer that there are 8 characters over here. So now we will have index equals to 0, and current character over here will be equals to the first character in S. So this will be C, and the character index will be 4. So we will put C at index 4. So 0, 1, 2, 3, 4. So I think this is the fourth. Yeah, this is the 5th character at index 4. Let's put C over here. Actually, yeah, it's okay. It's a little hard to see, but please bear with me. But if you go ahead and do the same for the rest, O is 5. So let's put O over here. Index 2, that's D. So D is 6. So 6. Index 3, we get E. And E is at index 7, so we get code. And you can see where this is going. If we assign it to 4, 4 will be pointing at L. And in this case, L has index 0, so let's change index 0 to L. Now at index 5, we get E. And in this case, for E, it has index of 2, so we will change this to E. Index 6, second last character, which is also at E. This is at index 1, so let's change this to E at index 1. And finally, index 7, that's the final character T, and this is going to be placed at index 3. So we get Leetcode like this. So we will return Leetcode, and that's pretty much it. Let's run this against some test cases. This passes, and let's submit this. And that's pretty much it for this algorithm. So let's look at the time complexity. Let n be the size of S. So in this case, we will initialize a shuffled string. Unfortunately, it's going to take O(n) time. Under the hood, when constructing a string object, this is a string object, by the way. And in this case, the number of, it's going to take as expensive as the number of characters in S. So yeah, under the hood, in the string constructor, it has to create these characters. So if you have a very long S, then the constructor will be more expensive in coming out with this string. So at the same time, we're also going to iterate through S and indices over here. So this is also going to take O(n) time. Fortunately, every single one of these operations here is O(1) under every iteration. So the overall time complexity of this for loop is going to be O(n). So the time complexity is O to n, but if we remove the base to simplify it, it will be O(n). Now let's take a look at the space complexity. Unfortunately, shuffled string is a copy of S, so this is going to be O(n) as well. And fortunately, in this case, index is a temporary variable. It's going to take O(1) space. Same for each of these temporary variables that are defined in the for loop over here. These two specifically. So this is going to be O(1) for this whole expression under the for loop. So the space complexity is going to be O(n). And that's pretty much it for this algorithm. I hope this was clear. And if you like it, please give us a like and subscribe. And we will see you in the next video.